look at logarithms, but before we do that, we're just going to finish off some exponentials that we didn't look at in the last video. So I told you that the derivative of e to the x is e to the x, but we're going to look at the derivative of e to the kx. Okay, is just some constant, and that's just equal to k e to the kx. And if you've seen the chain rule, you'll know how to get this result. So that's what we're going to look at with regards to that. Now we move on to logarithms, and the log is defined as the inverse of a to the x. So the inverse of a to the x, when applied to a to the x, has to return x, okay? So it has to sort of reverse this function of x. So if this is some h of x equals a to the x, then h minus of x applied to a to the x has to equal x. Okay? So the definition then is that log base a of a to the x is equal to x. But what does this function then tell us? Well, it tells us the power that we have to raise a to get whatever is in here. And what's in here is a to the x. So what power do we have to raise a to get a to the x? X. So this works in general if we have a to the x is equal to c, and no, a is greater than 0, x is greater than equal to 0, then log base a of c is equal to x. Okay, so that's the same definition. It's just a to the x is equal to c. But the point is, the answer you get is the power needed to get your input from the base. Special case is log base e, alright? And log base e of x denote ln x. So when you write ln x, that's the same as log base e. Often if you just see log written, so log x is normally equal to log base 10 of x, and sometimes it depends where you're at, because certain books you read log x is equal to log e to the x, but I'm not going to be using that notation. Just be aware of that. When I write log base e to the x, I'll write ln x. Let's draw the graph of ln x, and also note here that by this definition here, log a to the x, that means that ln x is the inverse of e to the x. Okay? And we're going to draw the graph. This is x, this is ln x, but yeah, y for now. And the graph looks like this. So it goes through 1 here, goes off on an asymptote with the y-axis, then shoots off slowly up here, okay? And interesting feature of this is, if we draw the graph y equals x, this is y equals ln x, and then we draw e to the x. Okay, just not much room, but this is y equals e to the x. You can see these are reflections in the line y equals x, and this is actually true for all inverse functions. Okay, the graph of the inverse of a function will be a reflection of the graph of the original function in the line y equals x. That's all we're going to cover on natural logs for now. We're going to go on to the laws of logarithms in the next video, but that's all we need to include for this one. If you do have any questions, let me know down in the comment section below. for now, that is it, and I hope to see you in the next one.